Hello learners, myself Dr. Alok Kumar Gupta, Academic Officer Physics, welcomes you at National Institute of Open Schooling, Noida. Learners, today our program is on topic Introduction to Ray Optics and its Application. For this program, our expert is Sri Sher Singh, Principal, Navigate School, Lodi Road, Delhi. So,
Hello.
learners, you know in our daily life how the important light is. Without light we can't see anything. So, light is very important. So, today we will discuss about it and its application with the help of our expert Sri Sher Singh sir.
Thank you, Dr. Gupta. The topic selected, Introduction of Ray Optics, is very interesting. Let us see. Ray optics deals with the direction of light propagation, and light is the form of energy which makes the object visible to us. You know it very well. And the direction of propagation of light can be changed by reflection of light and by refraction of light.
Sir, can we see the propagation of light through a medium?
Yes, we can see, and now there is a very small experiment, and now you can see this experiment. Now let us learn something more about the reflection. Reflection, when light falls on a rigid and smooth surface and comes back to the same medium, the phenomena is called reflection. In reflection, angle of incidence is always equal to the angle of reflection. Now you can see this reflection taking place in the slide. Here there is a smooth and rigid surface, and incident ray of light is coming as PQ and it is reflected as OQ. PO is incident ray and OQ is reflected ray, and one normal is drawn, and the angle between normal and PO incident ray is called incident angle, and the angle between normal and OQ, that is reflected ray, is called angle of reflection. So, angle I is always equal to angle R, but sometimes if surface is not smooth and rigid, then diffused reflection takes place. This is the diagram of diffused or irregular reflection. Here the incident ray coming are parallel, but the reflected ray are not parallel.
Sir, one question here.
Yes.
How does this diffused reflection is connected to our real life?
This is very important. As we see reflection in a plane mirror, there is the formation of a maze, but the light always coming from the object to our eyes, then only we can see.
Yes, right.
But if you are reading and writing anything on a paper, paper is not a smooth and rigid surface, but the light from the letters is reaching to our eyes. So, this is only due to diffused or irregular reflection, otherwise there will be the image formation of the reader in the newspaper, and we will not be able to read newspaper, books, etc. We will not able to see anything if all the surfaces are rigid and smooth, because everywhere there will be the image formation. So, we can see the word everywhere only we and we.
Okay.
So, this is only due to diffused reflection that we are able to see the object or what is the message written on a paper. So, this is very much connected, and it is as useful as the reflection of light, which we call the regular reflection.
Okay.
So, now let us learn something more. In reflection, there is no change in frequency, wavelength and speed of the light.
So, what about intensity?
Good questions. That intensity in reflection changes. There is no perfect mirror which can reflect 100% light, and this intensity changes as the change in amplitude. So, change in intensity, as you know that intensity is directly proportional to square of the amplitude. So, when amplitude decreases, the intensity in reflection
Of course, decreases.
also decreases.
Right.
Let us learn about the image formation due to reflection. When light falling on the object reaches or appear to reach our eyes after reflection, the image is formed. In this diagram, there is a mirror M dash, object O, and image formed I. Here light is coming from object O and reflect back in the same medium, but appear to meet at I. So, I is the image of O, but actually there is no light appear to reach here. So, this image is known as virtual image. In next diagram, you can see object AB and its image A dash B dash, which is formed due to the mirror. Again, same case is there.
Sir, one question.
Yes.
So, can we take a photograph of virtual image with the help of a camera?
It is a very good question. We can take photograph of image, object, and both image and object. Before going the diagram, we must learn that in plane mirror, image is always erect, virtual, and of same size as of object. Image is at the same distance behind the mirror as the object is from it. In response to your answer, we can see this diagram. Here there is object O, whose image is formed as I, and distance of object from the mirror is A. Same distance is of image from the mirror, and we have placed a camera C, which is at the distance of B. The important fact about it is, if the distance of the camera is focused for B minus A, then in the camera only object O will be focused.
Okay.
We will not be able to take the image I. If camera is focused for the distance B plus A, then in the camera only photograph of image will be focused. If we are taking with A very small tends to 0, then in the camera both object and image will be focused. So, this is a very related to our daily life, how a cameraman can play with the images formed in mirrors. And there is one important fact: when light is coming on a mirror and goes back, the angle of incidence and reflection both are 0. But if I rotate the mirror by angle theta, if I rotate the reflecting surface by angle theta, the reflected ray will be rotated by 2 theta without changing the direction of incident ray. And let us go about the fact which is used in many optical devices, many optical instruments such as periscope, sextant and optical levers. So, this is very important phenomena related to the reflection of light. Now, you can see its effect. You can see your image in a plane mirror, and there is a very important and interesting phenomena. There is a lateral inversion, left converted into right and right converted into left. You can see the image of letter R here. So, how this change is taking place? Only there is a change in 3-dimensional figure, and it is very important to know that the mirror actually reverses forward and back in 3 dimensions and not left to right. So, only Z direction is reversed, that you have already seen that only there is a reversal of Z direction, and we call this phenomena as lateral inversion of light. Secondly, there are so many image formations, and sometimes you may be worried about the size of the image.
Yes, sir. I have one question in
And-
keeping in my mind. So I want to know that what should be the actual size of mirror to see the full object.
Every part of the mirror is a complete mirror and there is a complete formation of image. But only difference is this, that intensity of the image vary. So if we are taking the different parts of the mirror, all the mirrors part are forming image at the same point and they increase the intensity. Now to see the full image of an object, we need the mirror of size which is half of the size of the object. That you can see in this diagram. There is a mirror and there is a position of I at E, and AB is the object and A dash B dash is the image formed. So here easily it can be proved that the size of the mirror M dash is half of the size of the object AB. You can see certain multiple reflection if you are taking more than one reflecting surfaces. So if we are taking two mirrors inclined at an angle theta, the number of image formed will be n, where n is given as m minus 1 for all position of object. Here m is 360 degree by theta and it is even integer, and this number of images n will be equal to m if m is odd integer and object is not at the bisector of the mirror angles.
How many images will form if two adjacent wall and ceiling of the roof are made mirror?
You can see this in a diagram. Here there is a diagram where we have taken two adjacent walls of the room as mirror. So number of images in the first diagram you can see there are 3,
Yeah.
because angle between them is 90 degree. 360 divided by theta is 4 minus 1, because one image of object O formed due to M1 mirror and another image M2 formed due to this mirror coincides. So one image is reduced and now ceiling is made mirror. So in second diagram you can see the ceiling is mirror and two adjacent walls are again mirror. So there is the formation of images and there is the reimposition of the images. So number of images reduced to 6 if object itself is observer. Otherwise it will be 7 if observer is someone else. The laws of reflection, that is angle of incidence is equal to angle of reflection, is equally applicable in spherical mirrors. Here in the diagram you can see concave mirror and the light ray which is coming parallel to the line which is passing through center of curvature, that is C, and pole, that is the midpoint of the mirror, and this line is known as principal axis. The light which is coming parallel to the principal axis has to pass through the principal axis at a point which is F. F is focal point. So the line which is passing through C and any part of the mirror is known as normal. So here you can see two angles I and R are equal, and also you can prove that CF is equal to FP. Let us see in convex mirror. This is a convex mirror. Light goes back to the same media, but it appears to pass from focus. In concave mirror it passes from focus, but in convex mirror it appears to pass from focus. So that is why this is a virtual focus. And now you can see in the form of mathematics, the focal length of the mirror is r by 2, where r is the radius of curvature. The converging or diverging power of the mirror is reciprocal of the focal length, where focal length is taken into meter and the unit will be the diopter. If an object is placed at a distance u and image is formed at a distance v, then its focal length can be related by this formula: 1 upon f is equal to 1 upon v plus 1 upon u. In spherical mirror, real and virtual both type of images are formed. Here you can see there is a concave mirror. In one side the image formed is real and the object is placed beyond C. C is center of curvature and its image is formed between C and F, that is the real image, because light rays are actually meeting at this point. And in second diagram you can see this is a concave mirror and object is placed between F and P, that is midpoint of the mirror, and its image is formed behind the mirror, which is larger in size, erect and virtual, because light rays are appearing to meet, actually they are not meeting. So, the object is AB and its image is A dash and B dash. Similarly, we can see in convex mirror, wherever is the object placed in convex mirror, its image is always formed between F and P, smaller in size and virtual. Here we can use this formula 1 upon F is equal to 1 upon V plus 1 upon U to find the position of the image. If we are putting U is equal to F in concave mirror, then V will be equal to infinity, image will be formed at infinity. If we are taking distance of object U is equal to F, which is less than 2F, then image will be formed beyond 2F, that is beyond center of curvature. If we are taking U equal to 2F, that is center of curvature, then image will also form at 2F, that is at center of curvature. If we are taking U greater than 2F, that is beyond center of curvature, then image will be formed between F and 2F, that is between focus and center of curvature. If we are taking U very large, that is equal to infinity, the image will be formed at focus. For convex mirror, for every value of U, the image will be at the distance less than F. It will always be virtual, erect and smaller in size, as you have seen in the first diagram. Now, let us take another phenomena which is called refraction of light. In refraction of light, when light passes from one medium to another, its speed changes, and due to which it may deviate from its original path. But for normal incidence, there is no deviation. You can see this is a medium and light is passing undeviated. But if this is oblique incidence, you can see in this diagram, for oblique incidence, the ratio of the speed of light in one medium to another medium remains constant, and it is called refractive index, denoted by N. This refractive index is determined by the law called Snell's law, and Snell's law says that the refractive index N is the ratio of sine of angle of incidence to the sine of angle of refraction. So, here there is a oblique incidence and angle I is the angle between incident ray and normal, angle R is the angle between refracted ray, that is O dash and normal. So, refractive index is sin I upon sin R.
Sir, one question, is there any change in the intensity of light during the refraction?
Oh yes, definitely. In refraction, first we must know about the refractive index, then I will try to answer your question. When light passing from air to glass, the refractive index will be denoted as NAG, which is equal to refractive index of glass divided by refractive index of air. So, we can write it Ng upon Na, and that is also equal to the speed ratio, speed in air divided by speed in glass or in any medium in which light is passing. So, if light is passing through number of medium coming out into the same medium, the multiplication of all refractive index will be equal, and this will be equal to the unity, that is 1. You can see here 1, 2, 3 medium, and light is again coming back to the 1 medium. So, here the refractive index of medium 1 with respect to 2 multiplied by refractive index of medium 2 with respect to 3 multiplied by refractive index of medium 3 with respect to 1 is equal to unity.
1.
This is called law of multiple refraction. And here, as you say that about the intensity. So, during refraction there is no change in the frequency of light, but there is a change in speed of light and there is a change in wavelength, which is given as the ratio of speed of light and frequency. But regarding intensity, during refraction there is also a change, and this change is given as I is equal to I naught exponential minus mu x, where mu is the coefficient of absorption and x is the length of the medium.
Okay.
So, this is how the intensity during refraction changes. In refraction, the objects do not found placed at their positions, but appear to be placed at another position, and the ratio of this real depth of the object and apparent depth remains equal, and this is equal to the refractive index. Now, you can see in this diagram O is the object, its image is formed at I, and we can see that object O is appearing at I. So, AO is the real depth of the object and AI is the apparent depth of the object, and the relation between real depth and apparent depth is refractive index is equal to real depth and apparent depth. Here it is very interesting that you may have seen at water trolley when waterman is selling water or lime water, they put lime into a tumbler filled with water and lemon appears bigger in size, so that it attracts the people that, oh, this is the very big lemon and it will give you the very good lemon water. However, the size of the lemon is very small. You can see here, this is the lemon of a smaller size. When it is placed in tumbler filled with water, it appears bigger in size.
Right.
So, here you have seen experimentally.
Yeah.
Now, in refraction, if light is passing from denser to rarer medium, the incidence angle is less than the angle of refraction, and if it is passing from rarer to denser medium, angle of incidence is greater than the angle of refraction. In first case, light will bend away from the normal, while in second case it will bend towards the normal. So, this is how bending of light takes place during the refraction. Here you can see in first case the light is coming from denser to rarer, and in second case the light is coming from rarer to denser medium. So, what happens when angle of incidence during refraction keeps on changing, and there is a particular position of angle of incidence for which angle of refraction is 90 degree. If angle of incidence is made greater than this particular angle of incidence, then light comes back into the same medium, and the phenomena is called total internal reflection. So, for total internal reflection, angle of incidence must be greater than the particular angle of incidence, that is known as critical angle. And let us see how this critical angle will be measured. The value of this critical angle is given as sine inverse 1 upon refractive index, and this is the refractive index of the material with respect to air. And this phenomena of total internal reflection is very much interestingly related to our daily life. Total internal reflection, this is a condition that the angle of incidence is greater than the critical angle, and light will come back to the same medium only when it is passing from denser to rarer medium. the significant application of total internal reflection you can see in our day to day life in optical fibers, and you know that everywhere there is a networking, telephone lines, these are using this optical fibers, and very interesting phenomena of mirage you can see, and the sparkling of diamond which gives very beautiful designs. We have a source of light, that is a laser light, and this is a laser gun, and laser gun is throwing the light which travels in a straight line, and it is coming out through this outlet, and this outlet will provide a jet, water of jet, through which this light should come, and let us see how it is coming. Let me allow this water to come out. Here you can see the light at the tip of the jet, but it is not visible in between, because in between when light comes from water which is a denser media to air which is rarer media, total internal reflection takes place and light is totally internally reflected. Phenomena is called total internal reflection. You have learned that how this ray optics is related to our daily life and how it is making the world around us beautiful for us.
Thank you, sir. You came in our studio. I hope our learner will be benefited after seeing this nice talk, and now they can learn how the light is important in our daily life, and they can imagine without light we can't see anything. So once again I thanks to Mr. Singh to came in our studio and giving a beautiful talk by which our learner will be too much benefited. Thank you, sir. Once again thanks.
Thank you.
जीवन ये प्रकाशित करने, राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने।
सीमा से विद्यालय जो मुक्त हो, धन साधन समय की सीमा से विद्यालय जो मुक्त हो।
कभी पढ़े हम कहीं पढ़े,